Die kids. It just found there too. It's really weird. And why are we gonna remember it? Here and here. Really close together. Just think of iodide when you think of the two. Are we good? Gustation. The dorsal surface of the tongue has taste buds that contain chemoreceptors, cells that bind dissolved food molecules, whatever. Okay? 1519 is very, very, very important. Salivary amylase, what does Amy do?
Breaks down carbs.
She wants to kill her carbs. Enzymatically cleaves starch into disaccharides, maltose, and oligosaccharides, dextrins. Okay? So we're taking all that carbohydrates and we're breaking it, cleaving it into disaccharides and oligosaccharides. What we're doing is salivary amylase does this via amylase. What amylase is going to do, amylase is going to cut the alpha-1,4, right? Because these carbs, what are they doing? They're cleaved, right? They're bonded. So what salivary amylase is going to do, Amy, what she could do is she could only break alpha-1,4. Good? But guess what, kids? What else is there? We have alpha-1,6s. Where are those going to get broken?
You don't.
Oh no, you definitely need, because we can do everything. We do alpha-1,4, we do alpha-1,6. We cannot do beta-1,4. Why?
Because we don't have an enzyme to cut it.
Okay.
Like cellulase.
Exactly. We do not have cellulase. Who has cellulase? Plants. Animals don't have it.
Oh, hello. Where?
Plants. And you're thinking some animals could do it, right? Why are you making this? Guess what they have in there? They have bacteria growing inside of them that could do this. And what is cellulase? What is cellulase, whatever? Fiber. Why is it fiber? It goes right down through you. And this is going to be important because I don't know if I have time to cover this. When stuff gets into your large intestine, your large intestine wall, you're gonna see some spots. It's very crazy. They're very thin. Okay? The muscle is very thin. And if you don't have dietary fiber, what's going to do is it stays thin, and you should say to me, how does it work? Well, dietary fiber goes through you, right? What it's going to do is going to make your feces bigger. When you make your feces bigger, what's wrapped around the feces? Large intestine, right? And the wall. When you make your feces bigger, when you eat fiber, it's going to stretch. And it's almost the same exact thing as me going to the gym. If I just lift it all day, what's gonna happen? I'm gonna look huge, right? Better shape. Because my muscles, I'm exercising them. Same exact thing. That's why you should have fiber. If you don't have fiber, you have stuff bad happening into your large intestine. Beta-1,4. Cellulase breaks it. You don't have it.
1,6. 1,6. I have that he said that
It can't do
break down
alpha-1,6.
alpha-1,6 either.
What?
Salivary amylase.
I didn't say anything about that.
Oh.
I said cellulase.
Cellulase.
I'm still in my beta-1,4. I'm not. Beta-1,4, I need cellulase to do it. None of us have cellulase, so it's fiber. Are we okay with that?
Mm-hmm.
Now let's go back into salivary amylase. Amy could only break alpha. She could only go to the gym 1 to 4. She cannot go to the gym 1 to 6. Okay? Alpha, very important. Amy cannot go to the gym alpha-1,6. Guess who could go to the gym alpha-1,6? We're going to see a brush border enzyme in the small intestine. And why should we remember it? Because whatever doesn't happen here, small intestine usually takes care of it. Right? So Amy does 1,4, small intestine does 1,6. And you can just think of Amy doing here and think of small intestine as her friend. Does two more hours, right? So what does it do? Not only takes care of, they both do 1,4, they both take care of 1,4, so there's that 2 left, and takes care of that. And I'm making these stupid analogies. It's just they don't make. I mean, it's just they make sense to understand it. But obviously, when we talk about these are the alpha 1/4s, and when they branch is the alpha 1/6. But just think of a retarded way to remember them. Are we
I just
good?
had a question.
Yes, go ahead.
You said the cellulose is beta 1/4s.
It's gonna break that.
Yeah.
Cellulose breaks beta 1/4s.
Yes, ma'am.
So we don't have.
But we do not have it. That's my whole point.
So it just
Right.
goes
We're
through.
alphas,
So that's
right? We are the alphas. The betas are plants. Are we good? Again, that's big. So make sure you know it. Slide 15, 20. Let me see if I'm on track or someone on track. Yeah, I'm good.
What time do you have to leave? What time do you have to leave?
5. Yeah. Oh, I'm not leaving early. Look how cool this is. Look at the product line. Look at this. Look at this duct. Isn't that cool as hell? There's like a freaking duct that just shoots in your mouth, which is pretty. I thought it was sweet. I mean, whatever. And you can see the submandibular and the sublingual, which is going to be by your salivary glands are innervated by the autonomic nervous system. This is really crazy. It's going to be innervated by the sympathetic nervous system, which is, I thought it was pretty cool.
Can you say that again?
Sure. Salivary glands are innervated by the autonomic nervous system, and the sympathetic nervous division of the autonomic nervous system, to be more exact. Okay?
But why was
I don't know. Because if you think about it, if you don't release these enzymes as you're eating, are you going to be, if you don't do the lingual lipases, right, which don't work in here, which we'll talk about, because they work, there's different pHs, right? There's a pH 7, pH of 2. It sounds weird, some of the stuff here only works good in here. And you're probably like, why? Because guess what? As it hooks up to the food, comes a bolus and goes in here, it's prepared. That's the thing. Even though it doesn't make sense, it prepares it to get into here. And if this doesn't happen, feed forward didn't happen, it would take forever for this process to happen, and we would die. So it's not in the same sense that we're gonna die, we're being chased by a bear, right? But it's important. Good? Because if these things are not secreted, again, 10%, maybe not even less than 10% is happening here, breaking down. But what's really important is the stuff that's coming out. Lingual lipases come out of the tongue, so that's very important too. So all these lipases, all these crazy things that are happening, they're preparing it to get into the stomach. Again, a lot of good stuff is happening in the stomach, but you know, like I said, the majority is still happening in the small intestine. Okay. The fact that it's innervated by the autonomic nervous system, it's going to be induced by the cephalic phase, and it's just like freaking attached to it. So, enteric nervous system can function by itself, just like the heart. But guess what? We have innervations all over it. And then we just talked about ACH and NE, acetylcholine and norepinephrine. Cool. Now we're gonna start to get a little juicy. Next slide, which is slide 1521. Dorsal surface of the tongue has a bunch of taste buds, and when food gets dissolved in water, it goes in these taste buds openings called taste pores, and it gets dissolved with the water, and it binds to mechanoreceptors. Just tell me when you guys are done. What's very cool about this picture